Hi, welcome to KEF Bytes YouTube channel. Today we're going to be doing part 2 in our Intro to Swift series. This is a series aimed at the beginner, someone who's just learning Swift, so if you have any experience in it at all, you probably just want to skip this and go look for one of my other videos. But if you're just getting started, then please follow along and go check out part 1 too if you didn't see it. So in part 1 of our series, we discussed variables and constants. Today, we will discuss the type of values that we can store in those vars and lets. Specifically, we're going to look at some of the built-in types in Swift. The things that will be the building blocks for building other more complex and custom data types. So without going any further into that, let's get started. You can see on my screen here, I've listed out some of the basic types. The first one we have is a bool. A bool holds one of two values, either true or false, and it defaults to false. The next one we have is an int. An int is a positive or negative whole number. It defaults to 0, and it can store 32 or 64 bits depending on the platform type. There's a couple variants of the int, which really just vary in the amount of memory they use. For instance, the int 8 can store 8 bits, the int 16 can store 16 bits, and then finally you have the uint, which also stores 32 or 64 bits, but cannot store negative numbers. Then finally, if we want to move on to numbers beyond the whole numbers, we have the float. A float stores numbers with decimals or fractions, and it's a 32-bit floating point number. A double is twice that size. It also stores decimals or fractions. It's a 32-bit floating point number, and it's the default. So when you create a number with a decimal in Swift without explicitly setting the type, it'll default to making it a double. A double is more precise than a float. We'll see that here in just a minute when we look at a couple lines of code. Two more types I want to talk about. We have the character, which stores a single character. It can be a letter, a number, an emoji, anything that's a single character, but you're going to have to wrap it in quotes and explicitly tell it it's of type character to get this particular data type. We'll see that as well. Finally, the last thing we have is a string, and a string is nothing more than a collection of characters. Okay, with all that said, let's look at a little bit of code. So we're going to start, again, with the bool, and I'm going to make a couple here, and the first one here I'm going to say is superhero, and I'm just going to set it to true. Very simple. There I am, declaring a var. Swift, being as smart as it is, implicitly infers that this is of type bool because it sees true on the right hand side of my equal operator. Now if I don't want to set it to an original value, I could create a var here and initialize it with one of its inits, and you'll see here once it runs that the bool default value is false. For my was born superhero variable, I did not set it to true or false. I just initialized it, and it takes the default value, which is false. Let's keep going by looking at an int. For the int, I think I will just use age, and I'm just going to set it to, we'll say 18. So Swift sees the 18 on the right hand side of my equal operator, says there's no decimal points. Let's set this to type int. Next thing, let's look at a double. We'll say height. We'll make this superhero 5'11", which is pretty short for a superhero. It's okay, we're going to go along with it. And again, Swift sees the right hand side of the operator, says, oh, there's decimals involved. My default thing is a double when there's decimals, so I'm going to make it a double. How can we check that? let's take a little sidestep here and look at something. I'm going to create an error here, but it is going to help us see something that I want to demonstrate. So this is going to throw an error. There it goes. But if you look over here at the error, you do see that it says the value of type double. So it's looking at height, and we are confirming now that height is of type double. Is this the same if I put age in there, which was our int, and ran it? We could see that age, even though we didn't tell it what type it is, was inferred to be of type int. So how do we make a float? Well, for a float, we are actually going to have to explicitly say be of type float. And let's go ahead and put this back to height. Now, once it throws our error, we can see that height now is of type float. Let me go ahead and remove that. When we move on, so we removed it. It'll change back to double. There we go. And everything is right. Okay. The next thing we're going to look at is a character. We'll use sex for that. And remember I said when we talked about character a minute ago, you actually have to tell it it's going to be of type character, and you have to put it in quotes. So for sex, I'll say M for male, and then we're going to use the same thing we just did here a minute ago, so we can check the type. So again, we'll throw the same error, and it's going to tell us that sex is of type character, just like we think it should be because we explicitly said it. But what if we removed that? Then what's it going to be? Well, it's going to default to a type string. This is why when we have a character, we need to explicitly say it is of type character. Whoops. Like that. Now to go back to character, and we're all set there. Finally, our last type that we're going to look at is type string. I don't know why I'm trying to type string. Just type in whatever I'm thinking in my mind. And here we will make a string. And if we want to do the same thing as we were doing before, we can confirm that. Throw our error. And we see it's of type string. Now this is not the only way you can check the type of one of your data types. It's just a real easy way for me to show it to you here in this video without taking too much time or getting too deep into other things. Okay, anyway, so there are our data types demonstrated. Now, we talked up here, remember we were looking at our commented out types up here. We said that a double is more precise than a float. Let's take a look at that real quick. So let's just create two variables. We'll say float var equals a big number here. And then let's do one for a double using the same number. So just go ahead and copy that. And then we'll print those values. And I'm going to have a problem here, but it's a good demonstration. So we'll see it once we get going here. You may have picked up on the problem from what we said earlier about having to explicitly tell something it is a float. But let's see it in action here before I change it and fix it. Okay, let's go ahead and run this. And we can see that we still have those errors from earlier. Don't worry about that. We can see that our float is really a double. That's what I wanted to show you here. So we need to explicitly tell the float that it's going to be a float. Then let's run it again. There we go. We've got a clean console. And now you can see the difference between our float and our double. They both get instantiated with the same number, as you see there. But when we go to print them, you'll see the float rounds the number down because it can only hold so many decimal places. That is why the double is more precise than the float. The last thing we'll do today, before we move on, is we talked about these being simple data types that are built into the Swift language, but they're also the building blocks to building more complex, more custom data types. So before we leave today, let's look at that real quick. And I'm just going to create a data type named hero. We'll move all this in there and just demonstrate that we created our own custom data type, which is hero, but it's built from the building blocks of all these simple data types. All right, there you go. That's it for today. Again, very simple lesson. That was part 2 of Intro to Swift. In part 3, we're going to start looking at optionals. We'll start looking at more in-depth pieces of the Swift language. But we had to get these 2 pieces of the variable and constant and then the data types behind us so that we could build off of them. If you've enjoyed these 2 videos or any of my other videos, please subscribe to me on YouTube. And if you want to help support me creating more videos in the future, you can make it worth my while by going to the App Store, downloading this lovely Barkulator app. It's a very simple app. It translates what your dog says into human readable sentences. Very silly app. Good for about 5 minutes of entertainment. I did it one day just as a little test run, but as it turns out, it's a real good way for you to help support this YouTube channel and for me to create more videos just by going and spending 99 cents and download the app. I'd appreciate it. Thanks for joining me today, and we'll see you next time.